All right, it's 9 o'clock. Good morning, everybody. If you were able to come in early, then you had a chance to take a look at this warm up. So, we're going to be taking the reason why we're doing this warm up is we're going to be taking these angle pairs and we're going to be building relationships using deductive reasoning. And that's what we're going to do today. And the important thing today is taking good notes because remember, everything is open notes. So what's really important, guys, is that you take good notes. You don't have to memorize everything. You just have to make sure you can look it up your notes and see what's going on. So that's really important for today. So let's start off by reviewing this because this is going to be what we're talking about today. We're going to extend on this. So with corresponding, right, with corresponding angles, we're looking for angles that are in the same location. So last class we talked about, we can think of these groups of angles as cities, right? So I have this top city and I have this bottom city. Now remember, we're focusing on things that connect cities. We already have angle rules that work only within cities. So for example, 4 and 6 would be a linear pair, and a linear pair would mean they add up to 180 degrees. Also, 4 and 8 would be a vertical angle pair, and that would mean that they're equal, right? So we've already spent time talking about vertical angles and linear pairs, right? So what we're focusing on is how do we connect these cities? And I hope that analogy works, right? So again, we have linear pair and vertical angles. Those work within your city, and then these are going to be things that connect cities. Right? So I don't want you guys to lose that because we're going to do some proofs and we're going to have to be able to use both connecting cities and within cities. Okay? So for corresponding, so these four are all connecting cities. So when I'm looking for corresponding, I think location. So for example, 4 here is in the upper left and then 7 down here is in the upper left. So I would have angle 4 and angle 7 are corresponding angles. And again, with corresponding, we're connecting the cities. We're looking for the same location. So if this one up top is Bellingham, then the northwest of Bellingham is corresponding to the northwest of Mount Vernon. Okay? So if we do 4 and 7, does someone want to suggest another pair? So in chat, you can type in another pair. What other angles do we have, guys? So for corresponding, can someone type into chat what we have for corresponding angles? Yeah, 6 and 3. So that is the upper right with the upper right. So I can say angle 6 and angle 3. And I know you guys, it's hard to type an angle into chat, but make sure when you're writing in your notes, it's angle, right? Angle 6 and angle 3. Okay? All right, cool. Yeah, and there's a lot of them, right? 1 would go with 5, 8 would go with 2. There's going to be 4, and the reason why there's going to be 4 is that these cities are split up into 4 parts, right? The upper left, the upper right, the lower right. Okay? So now let's take a look at alternate interior. So we talked about alternate last class. Alternate means to switch sides of the transversal. So if you don't have that from your notes last time, you want to add that in. Alternate means to switch sides of the transversal. Alternate means switch. So we're going to switch sides of this transversal. Interior means inside, right? So this is the inside. Okay. Now, remember, 1 and 8 are on opposite sides of the transversal, but they're a linear pair, right? And see how they're in the same city. So this already has a name. This is a linear pair, right? So alternate interior connects cities. So it can't be 1 and 8 because that's a linear pair. It already has a name. It doesn't need a new name. So if I'm going to switch sides and stay on the inside, the only other angle on the inside that's on the other side of the transversal is angle 3. So it would have to be angle 1 and angle 3. Okay, so angle 1 and angle 3 are alternate interior. Okay, if I go to 7, same thing. I can't be 7 and 3 because that's a linear pair. So the only other option is angle 7 and angle 8. Oops, that's not what I want to do. And angle 8. Okay. And again, if you guys have questions, please ask questions in chat or turn on your mic and ask questions. Okay. So exterior, so we're still alternating, but exterior just means outside. So the outside, this is like a sandwich, right? Is going to be above and below the inside. Okay, so my outside angles are 4, 6, and 5, and 2. So if I take a look at 4, I want to alternate sides of the transversal, but 4 and 6 already have a name. That's a linear pair. So the only other angle it can go with is angle 2. So I have angle 4 and angle 2. And then I can do the same thing with 6, right? It'd be 6 and 5. Okay. Now, consecutive for this next one, consecutive means one right after another. For example, the numbers 1, 2, 3, 4 are consecutive numbers, right? And interior, we're on the inside. Well, if we're doing this, you can actually just get these by process of elimination. 1 and 8 is a linear pair. 1 and 3 are alternate interior, which only leaves 1 and 7, right? That's the only pair that we haven't named yet. So notice how they are inside. They don't say alternate. And what they mean by consecutive, it's the next angle on that side of the transversal. Okay? So 1 and 7 are consecutive interior. And angle 8 and angle 3 are consecutive interior. Okay? So that's what we talked about last class. It's super important that you guys have this because we're expanding on this today. We're building on this today. That's why I chose to start class with doing this. So if there's any questions on that, you can ask in chat or you can turn on your mic and ask as well. Now that a lot more people are here, I just want to, I was checking up on Skyward. There's a lot of you that didn't take the midterm. Guys, that is super not okay and super bad. You need to take your midterm. At this point, it is late. So you need to email me and communicate with me so we can figure out when to get your midterm in so I can get it graded. If you just turn in your midterm now, I won't know you turned it in. So you need to communicate with me about your midterm. Also, a lot of you guys have missing assignments. Remember that 80% of your grade is these assignments. Remember that you can redo any assignment as many times as you want. So if you turn in an assignment and you don't get a grade you like, you can email me and say, hey, I want to redo assignment 3.2, and boom, you can redo 3.2. Okay? If you need help, you can come to my office hours and we can do the homework together. On that note, my office hours are changing because of coaching. So starting next week, Monday, Tuesday, Thursday, Friday, my office hours, all of them are going to be in the morning from 6:35 to 8:50. I coach girls soccer and boys soccer. All right, so let's go ahead and dive into our lesson. So our lesson today, and those are my announcements. And if you guys have questions about that or you want to chat, we can do so at the end of class today, or you can send me an email. All right, so let's talk. Our lesson today is if parallel lines then ... Isn't that suspenseful? It's like, ooh, what's he going to do? And just if you guys are keeping track within the book, we're in section 3.2. So if you're keeping track of that. Okay. All right. So what does this mean? Well, do you guys recognize the if then format? This is a conditional statement. And remember, conditional statements are deductive reasoning. I know a lot of you guys are like, why are we doing this? Well, this is why, right? We need to bring in deductive reasoning because deductive reasoning are rules. Right? These are just relationships, right? We're just like, okay, these angles have a name. So we want to take those angle relationships and make them angle rules, right? So we want to be able to make them rules so that we can use them to prove other things. These angles are super important, and you're going to see today, if you ever build something and it has angles in it, we want to be able to use these rules so that if we cut one angle, we don't need to measure every single angle. And I'll show you and a couple of examples in that. So this is actually really useful in designing and building things because if you ever designed and build things, having to measure angles and cutting everything can take a lot of time. So if you know this stuff, it saves you a lot of time and makes building and construction a lot faster. Okay? So if parallel lines then. So what we're going to do is we're going to see. So let's talk about this. Let's see if you guys remember last class. Are these two lines parallel? Type yes or no into chat. Are these two lines parallel? So in chat, just say, are these two lines parallel? Yes or no? So I'm getting a little bit of different answers. I'm getting some people saying yes. I'm getting some people saying no. I appreciate you guys participating because this tells me where we are, right? So now, when you look at this, it looks like they're parallel, right? Like it looks like I'm doing that. But remember, there's two things that are not true. One, I do not have the superpower of drawing perfectly parallel lines by just my hand and my eye. And two, we both don't have the superpower of being able to tell if those are parallel. Okay? So I really want to drive home, guys. If it doesn't say they're parallel, then you can't say they're parallel. Now you might say, they look really close to being parallel, or they look like they might be parallel, right? But if you're building something like that's important, like a house or a building, you can't just be like, that looks like a right angle, right? Because then the whole house could be off, and then that's, no one wants to pay money for that, okay? So these are not parallel because it has nothing saying that they're parallel. So when I say if parallel lines, we can't just assume they're parallel. So again, let's try this again. If I have two lines like this, A and B, as given, are these lines parallel? And what should the answer be, everybody? What can you guys say? Absolutely not. Okay? Now they could be, but to fix this, the easy fix, because I can tell you I can't, right, without a ruler and a compass, I can't construct these. But what I can do is I can just go like this. And if I add those extra little arrows on there, that means they're parallel. So it doesn't require any superhuman powers. It doesn't require any fancy tools. We go like that, then we all know those two lines are meant to be parallel. Okay, even if they don't look like they're parallel because I'm not a great drawer, right? Okay. So that's an important piece that we need to take home. Now, for these next parts, I want you guys to know if we were in person, I would show you how to construct parallel lines, right? I would show you how to actually make, like, you could be like, these lines are parallel, right? So, but we don't have time to do that, and we don't have tools. We don't have compasses. We don't have those tools for everybody. Now, part of that also means that these next things I can't prove to you, and I want you to know that the one thing I know people hate about math is that there's always some old white guy telling you, hey, these things are true, and then you just have to open up your ears and like just let it come in, right? And that's like really frustrating, right? Like, when can we like do something so we control the learning? Well, math is actually supposed to be, you should be able to prove everything. And so I just want you guys to know I'm really sad that I can't prove this stuff for you because we skipped construction. And so I can't do these proofs. So for right now, what I want you guys to know is, remember, this year everything's open note. So just make sure you get these in your notes. You know how to see them and you know how to use them. Does that make sense? And I'm really sorry that I can't prove them for you. Because even if I did prove them for you, it would take so much time and it wouldn't make a lot of sense because I haven't taught you all the constructions. Okay? So basically, with that said, and I'm just apologizing because I want to be better for you, what I'm going to do is, if we have parallel lines, so notice how these lines, they weren't parallel. We're going to investigate what happens to these angle relationships when things are parallel. Okay, that's the goal. So when the lines are parallel, what happens with these angle relationships? So we're going to do two at a time here. There's four. So the first one, we're going to say if parallel lines, then, and I'm going to write that in black because that's kind of our script, right? So if parallel, then, and then I'm going to say corresponding angles are congruent. Sorry, I have to use shorthand a little bit, and I'll teach you guys more shorthand as we get going. But this is if parallel lines, then corresponding angles are congruent. Now, again, it's like, well, why are they congruent? Guys, I'm really sorry. If we were in person, if we were in class, I would show you that they in fact are congruent, like undeniably. And I'm sorry that we don't have the time to do that. You're just gonna have to take me for my word here. Okay, so let's take a look at another example here. So I'm gonna draw 2 lines, and then I'm gonna make them parallel. Now notice here I do 2 additional lines, right? Just to show that if this was line C and line D, that line C and D are parallel, but they're not parallel to A and B, right? So sometimes we add more arrows just to show that, hey, these 2 are parallel, but they're not parallel to these 2. Okay. Minor thing. All right. I'm going to add a transversal, right? Transversal goes all the way across. And then I'm going to add in some angles. And I'm just going to generate random numbers so people don't try to memorize, because that's going to hurt them in the long run. So I'm going to have 10, 11, 12, 13, 5, 6, 7, and 8. Now remember, there's no degree symbols on these, so these are just names. I'm just naming those angles. Okay. So remember, when we're doing deductive reasoning, we're robots. So this is what we're going to do as robots. If parallel lines, then corresponding angles are congruent. Okay. So my robots, tell me, do we have parallel lines? Is this condition met? Yeah, this condition is met. You guys get it. You guys get it. So this condition is met. So then what has to happen? Corresponding angles are congruent. That has to happen. So the first thing we need to do, and this is what we worked on last class, is we need to identify corresponding angles. So remember, this is going to connect us from one city to the next. So I look up here. On the top, I have 11. And then I'm down here on the top, I have 6. So then, since the lines are parallel, I can say angle 11 is congruent to angle 6. And what does congruent mean? Congruent means same size, same shape. So that means whatever value 11 is, angle 11 is, then angle 6 is that same value. And this is going to be huge, guys. This is going to be huge for doing stuff. Okay, so in chat, can you guys tell me what other angles are congruent? Now, I know on your keyboard you don't have a symbol for congruent, so can you just use the number and equals? Can you guys tell me what angles are going to be congruent? Now, you can just use numbers and the equal sign. The equal sign, by the way, is next to backspace. Right hand. Okay, so I see 13 and 7. So angle 13 is congruent to angle 7. See how 13 here is kind of on the right side? 7's kind of right here on the right side, right? So 13 and 7. And then, ooh, we got another one, 10 and 5. That's so funny. Like, I got a whole bunch 10 of 5s at the same time. So 10's on the left, 5's on the left. So I can say angle 10 is congruent to angle 5. And then while I was writing that, I got a couple more. Yeah, there's one more. A couple people got me this last one. So 12 here's on the bottom, 8 here's on the bottom. So I can say angle 12 is congruent to angle 8. Now remember, corresponding goes by location, location, location. So it has nothing to do with the numbers. It has to do the top with the top, the left with the left, the bottom with the bottom. Okay? All right. So if parallel lines, then corresponding angles are congruent. Now, I want to be super clear on this. If the lines aren't parallel, we can't say they're congruent. Do you guys see here? I didn't say they were congruent. I just said they are corresponding angles. Okay? So I really want to drive that home. This is only true if there's parallel lines. If they're not parallel, they're still corresponding angles, but they're not congruent. Like, imagine if I'm comparing 2 cities, right? But they're really different cities, then they're probably not going to be congruent. Okay, that analogy maybe is not the best, but that's what's going on there. So if parallel lines, then corresponding angles are congruent. Okay. And please let me know if I'm going too fast. Hopefully this is a good speed. All right, our second one is going to be if parallel lines then, right? So that's kind of our the phrase of the day, right? If parallel lines, then, and what we're going to say is alternate. And it's important, I always have students call this alternative. It's not alternative rock, it's alternate. Alternate interior angles are congruent. Okay, if parallel lines, then alternate interior angles are congruent. So let's go ahead and draw a picture. So I'm just going to switch up what my parallel lines look like. They're not parallel yet, right? So I'm going to add, in this case, I'm going to add 3 arrows just to get you guys used to seeing different symbols. Okay, I'm going to draw a transversal. And I'm going to add in some angle numbers. Okay, so I'm going to start at the bottom here. On the top, I'm going to put a 1. And then I'm going to put a 2, a 3, and a 4. And then up top here, I'm going to start at the top. And I'm going to put 21. To the right, I'm going to put 22. And then down below, I'm going to put 23. And then on the left, I'm going to put 24. Okay. So again, we're going to be robots. Okay. So if parallel lines, so let's check. Do we have parallel lines? We sure do, right? And again, they don't look, they're not drawn super well, but we know they're parallel because the arrows tell us, the extra arrows. Okay. Then alternate interior angles are congruent. So what we're looking for is alternate interior. So they're on the inside, right? So we have the inside, and they're going to be switching. So if I have angle 1, I know that if I have parallel lines, then angle 1 is going to be congruent to angle what? What's angle 1 going to be congruent to? Maybe I'm going too fast. Usually a sign of no one typing in chat means I'm going too fast. Yeah, I'm starting to get some answers now. Ooh, you guys are doing really well. Yeah. So angle 1 would be congruent to angle 23, right? Because they are alternate interior angles. I will slow down a little bit. Okay. So again, the way this is happening is this is only true if they're parallel, right? So we have parallel lines. So again, alternate interior angles always exist. But it's the new part here. What's new is that they're congruent. So if parallel, then these babies are congruent. Okay? So we have angle 1 and 23, right? They're a pair of alternate interior, so they're going to be congruent. Now my other pair of alternate interior is going to be angle 2 and angle what? Ooh, some people are like already throwing answers in. Right, so I'm going to have angle 2 is congruent to, ooh, I like the use of that. It's not quite the angle symbol, but it's pretty dang close. I like that. Right, it's going to be angle 24. Okay? All right. So all we're doing, guys, is we're taking these angle relationships that we talked about last class, and we're saying if we have parallel lines, then they happen to be congruent. Okay? So we're going to take a break from taking notes just for a second, and we're going to take and then a reminder, and then we'll do a little practice. Oh my gosh, we're running out of time. We're going to have some time issues today. All right, so here we go. Just one last note. Linear pair and vertical angles So linear pairs and vertical angles do not need parallel lines. Okay? Linear pairs and vertical angles do not need parallel lines. If you want to use our analogy, and I'll put these in quotes, they only work in the city. They only work within the city. Okay? That means there's no transversal, right? That they only work within the city. They're not connecting the city. I just really want to make sure you guys know that. So linear pairs and vertical angles do not need parallel lines. All right. What we're going to do here is we're going to do an example. I'm a little worried that we're running out of time. Okay, so sketch this down really quickly. And I'm going to add some numbers. Be careful where you put these numbers. So I'm going to have in the upper right of this left city, I'm going to have a 1, and then a 2, and then a 3. I'm leaving this upper left one blank. And then I'm going to have 4, 5, 6, 7. So I labeled 7 of the 8 angles. Okay, I labeled 7 of the 8 angles. And then what I'm going to do up here in the upper left, I'm going to call that 120 degrees. And what we need to do is we need to find the measure. So we're going to find the measure of each missing angle. Okay, so we're going to find the measure of each missing angle, and we're going to say what angle rule we used. Okay. All right, so we're going to find the measure of each missing angle, and we're going to say what angle rule we use. Now think about this, guys. If I'm building something, I'm making the claim that you only need to know one angle. And by knowing one angle, you know all the rest of the angles. And this is an awesome building trick, right? Because if you only have to measure one angle, then you're good for the rest of the project. Now, a lot of builders do this with 90-degree angles. If they can start with one 90-degree angle using a builder's tool, which is a right angle, right? It's a piece of metal that's shaped as a right angle. Then they don't even have to measure it, right? They just set it up and make sure everything's level. Well, usually you have to make sure the ground's level, then use that. Okay? So, again, put a lot of time into getting this angle correct, and then everything else is perfect, right? And then that's usually what builders do. Okay? Not always, but usually. So what we're going to do is we're going to find the measure of each angle. And I'm writing the measure of angle 1, the measure of angle 2, the measure of angle 3, and so on, all the way to the measure of angle 7. Okay. I'm worried for time. All right. I do want to talk about some things. So some of you are probably already solving this. Okay, I just want to point this out. There is never just one way to solve problems. Okay? So just like there's never just one way to build a home. Okay? There's so many different ways of doing it. And at the end, all that matters is that you get the right answer, right? So in this sense, it's not so, and especially when you're buying a home, it's not so much that the home is built, is how is the home made, right? You want to know that quality was going into it. So yes, we're going to find the measure of the missing angle, but what's really important and what's more important is what angle rules did we get there? Because everyone could use different angle rules, okay? So remember in your work, it's really important to say what angle rule we used. So for example, I could start by finding a lot of different angles. I don't have to start by finding angle 1. So what do I mean by that? Well, if I take a look, I see, oh, hey, in this, right, if I look at just that city, right, I notice, don't I have an X? And then isn't 120 and angle 2, aren't those vertical angles? Yeah. So then I know vertical angles are congruent, so that means angle 2 would be 120 degrees, and I did that using vertical angles. Okay. Now, you didn't have to start on angle 2, right? You don't have to, but I did. And it doesn't matter where I start, because I said this is it and this is why, and so boom, there you are. It's like, oh, okay, it's 120. Okay. And then I might say, okay, well, let's do angle 1. So in chat, what angle relationship is this between 120 and, I'm trying to cover those up, 120 and angle 1? Can you guys type it in chat? What angle relationship is that? Yeah. So what angle relationship? Here, I'll give a hint by pushing my paper. Yeah, linear pairs. I mean, they are consecutive. They are. Yeah. So when you say they are consecutive, they are. The angle rule that we're looking for, though, is linear pairs. Because what do linear pairs say? It says two adjacent angles on a line, right, are going to be supplementary, which means they're going to add up to 180 degrees. So that is, for this angle right here, I'm just going to write some math, that angle 1 plus 120 degrees is going to equal 180 degrees, right? This is a linear pair because they're on a straight line, and the angle for a straight line is 180, right? This is angle addition. But instead of writing all of that, we just write linear pairs. It's shorter, easier to remember, okay? So if I want to solve here, I would subtract 120 from both sides. So taking a look at my calculator here, I'm going to take 180 minus 120, and I get 60. So then I know that angle 1 is 60 degrees, and I found it by using a linear pair. Okay. So there I go. And you guys, that was cool. It's cool that a lot of you saw that it was a linear pair, and cool that you saw that it was consecutive, because that's also true. Just not maybe the angle rule we're looking for. Well, if I know this is 60, then isn't angle 1 and 3, aren't those vertical angles? So then angle 3 has to be the same. Now, I didn't have to use vertical angles for 3. Could I have done another linear pair? Yeah, I could have done another linear pair. I could have done a linear pair with angle 3 and 120, or I could have done a linear pair with 3 and 2, right? Because we said 2 is also 120. Oh my gosh, are you guys seeing how it's all coming together? I know I couldn't prove this for you, but this couldn't work unless it was all true. All right, so what we did, we just found angles 1, 2, and 3. So we just found all the angles in this city. But what we're learning about today is how to connect cities, right? So we have two ways to connect cities, right? We can connect the cities by corresponding angles, or we can connect cities by alternate interior. So take a look at here. Did you notice these lines are parallel, right? So these are parallel. I just wanted to throw that in there in case people are struggling. So these are parallel because of the arrows. Okay. So I could use a bunch of different things. So for example, I could say, see how 120 degrees here is in the upper left? Well, angle 4 is in the upper left. So these two would be corresponding angles. And if they're parallel, then I know they're congruent. So angle 4 is going to be 120 degrees because if parallel lines, then corresponding angles are congruent. Now, you might be saying to yourself, crap, there's no way you're going to have me write that much text every time just to write down an answer. You're right, it's a lot of text. So I'm going to show you guys some shorthand, right, to make it look like a little bit shorter. Now I'm going to warn you, when I say shorthand, I mean this is department approved, as in all the geometry teachers approve of this shorthand. You can't make up your own shorthand, okay? Just like you can't like make up your own language and then write in that language, okay? So let's talk about that using the next one. Okay. So in this case, I said angle 4. Well, what if I want to find angle 7? Well, if I look at angle 7, if I look at angle 7 is here. So I have 7 and I have 1. Aren't those alternate interior angles? Well, I know angle 1. And if I have parallel lines, then alternate interior are congruent. So I can say angle 7 is going to be the same as angle 1, and angle 1 is 60. So to abbreviate this, I can say if parallel lines, then alternate interior angles are congruent. And that saves us a bunch of times. So I use the parallel line symbol instead of writing parallel lines. And then I use 3 letters, at least 3 letters, to abbreviate the long words. Pretty cool, right? And that's pretty cool shorthand. Okay. Now, to get the rest, to get 5 and 6, I could use linear pairs, I could use vertical angles, I could use corresponding. You guys see how there's a lot of different ways to do this. I'm lazy, and I'm just going to use vertical angles. So 5 is going to be congruent to 7 because of vertical angles. Right? 5 and 7 are going to be congruent. And then 6 is going to be the same as 4 because of vertical angles. Okay. Now, notice how cool that is. I got all of these angles, and all I had to do was measure once. Okay, so this is powerful. We want to be able to use this. We're going to be able to tie everything together with it. It's going to be great. Now I'm looking. It's 9:37. We get out at 9:50, so I have about 23 minutes left. Did I do that math right? Yeah. No, I have 13. Sorry, 13 minutes left. 23 sounded like a lot. I have 13 minutes left. Okay, so that was an example. So just want you guys to know there's going to be some problems on your homework, and the midterm is done. So remember, everything we learn now is going to be on the final. The final only has the content after the midterm. So this stuff is going to be on your homework and on the final exam. It's not really a final. It's just the second part exam. Okay. So for that, we're going to just make sure, if given one angle, using these angle rules, we can find the other stuff. Okay. Well, we only looked at 2 of those city connectors ones, right? There's actually 2 more. So I'm going to go ahead and finish up those notes. Okay. The reason why I just focused on those 2, those are your bread and butter. They're the most important. These other 2 are situational, and they just kind of make your life easier. But they do show up. There's going to be 1 or 2 of these in your future. Okay. So the third one is if parallel lines then, right? That's the phrase of the day. If parallel lines, then I'm going, and I'll use abbreviations now. Alternate exterior angles will be congruent. Okay. So if parallel lines, then alternate exterior angles are congruent. So what does that look like? Well, I'm going to draw a pair of parallel lines with a transversal. And I'm just going to draw some stars. So if this was a star and this was a star, then angle star would be congruent to angle star. It's just a little bit easier that way. And then let's just do another color too. I would have a box and a box. So angle box would be congruent to angle box. Man, I feel like I got some pen in my nose and it's like burning me. Ah, super frustrating. All right. So again, alternate exterior. It's good to know, but just remember you don't have to use it. You can always use vertical angles and linear pairs and get the same thing. Okay. And then the other one, I want to make sure you guys get that. So we're just drawing this picture and just saying, hey, alternate exterior would be congruent if we have parallel lines, right? So it's the same relationship, but now they're congruent because we have parallel lines. Okay. And then I'm going to use complete shorthand in this one. So if parallel lines, then consecutive interior angles are supplementary. And I know I wrote out the word supplementary because I just want to make sure you guys know that means add up to 180, right? So consecutive interior and linear pair have something in common, right? Linear pair add up to 180, consecutive interior add up to 180. If you want to abbreviate supplementary, I would abbreviate it as sup. Like, yo, what's up? Okay. Okay. So in this case, if parallel lines, then consecutive interior angles are supplementary. So what does that look like? Well, let's say I have some parallel lines here. Okay, and so again, we're looking at consecutive interior. So I'm on the inside and I'm on the same side of the transversal. Okay, so A and B would be consecutive. But now we have to really focus on supplementary. Everything else has been congruent, but this one's going to be angle A plus angle B equals 180 degrees. So again, just like linear pair. So it's just like linear pair. Linear pair and this one are the only two that add up to 180. Everything else is congruent. So we just have to watch out for linear pairs and consecutive, right? Because if we can set it up right, we can avoid those as much as we can, right? Now remember, the reason why I separated these two is they're convenient. In your homework, one of these will show up. So there you go. You're still going to have to use it. But they're mostly just for convenience. But they do show up, and they are really convenient. So that's why I'm teaching them to you. Okay. So, oh my gosh, I got 7 minutes left. And in my 7 minutes, I want to try another problem with you. We're going to add in algebra. And then I'm going to want you guys to try one on your own. Okay. And that's why I was worried about time, because you know that just watching me isn't as good as you doing it and seeing what you need to work on. Okay. So let's do a couple examples. Okay, so I'm going to add into algebra, right? So we're going to do example 2, and this is with algebra. Okay, so I'm going to go ahead and make some horizontal parallel lines. And I usually just use one additional arrow for parallel because I'm lazy and I don't want to draw a whole bunch of arrows. Okay. So let's go here. I'm going to write, where is my blue pen? Oh, there it is. I'm going to put in the upper right, I'm going to put 115 degrees. And then down here, I'm going to put x plus 5, and then I put it in parentheses with a degree symbol, so you guys know I'm not talking about a segment, I'm talking about an angle. I'm talking about shaft. Can you dig it? All right, so our goal here is to find the value of x. All right, so I didn't just add algebra. I add in a multi-step problem. This is a multi-step with algebra and multi-step. Because looking at this, is there an angle relationship that gets me directly from an outside angle to an inside angle? Well, if you don't know the answer, you can check. Are they corresponding angles? Well, this is in the upper right, and the upper right is down here. So they're not corresponding angles. Are they alternate interior? No, interior is here. See how this 115 is not in the inside? Are they alternate exterior? No, this angle isn't on the outside. Are they consecutive interior? No, this angle isn't on the inside. So right now, we don't have a direct relationship to get from 115 to x plus 5. So we're going to have to go in multiple steps. And here's the cool part, guys. There's no correct way to get there. Now, there's a shortest way. And so I'm going to teach you the shortest way. But you can get from here to here in 2 steps. And that's going to be the shortest way. So, for example, if this is 115, what else can be 115? Right? So there's a whole bunch of different ways we could do that. We could do vertical angles. Right? This would be 115. We could do if parallel lines, then corresponding angles are congruent. Right? We could do, oh wait, there's more. We could do a linear pair. So if I did a linear pair, I would have to do 180 minus 115. So I could get 65. Okay. Now, as you guys can see, I could keep going with this. Couldn't I find all the angles in this picture? Like, we've already done that, right? But the point is, I'm wasting time. I don't care about all the angles in this picture. I only care about this angle. So I want to try to get there as in little steps as possible. So I wouldn't want you to find all these angles. You're spending way too much time on this problem. But the point is look at these 3 angles that I found. I could also do alternate exterior, right? But what I could do now is all these angles I found have a relationship with this unknown angle. For example, these 2. Isn't this a linear pair? For example, these 2. Aren't those consecutive interior? Or these 2. Aren't those corresponding? So the whole point is, if you can't get there directly, find one other angle and then keep going. So I'm going to go and I'm going to start out with a linear pair. So I'm going to say 115 degrees plus some angle equals 180 degrees. That's a linear pair. So we found this box to be 65 degrees. Okay. So this was step 1. Step 2, I'm going to say, hey, this angle right here and this angle right here, they're corresponding angles. So that means that 65 equals x plus 5, because if parallel lines, then corresponding angles are congruent. Okay. And again, guys, I know this seems complex because I'm showing you all the different ways to solve it at once, right? So I chose to do a linear pair first and then corresponding. I could have done vertical angles and then consecutive interior. I could have done corresponding and then linear pair, right? I could have switched this order. I could have done alternate exterior and then linear pair. Okay. If you guys are really daring, you could have done linear pair then alternate exterior, right? But the algebra is a little weird there and it gets weird, okay? So I go ahead and I solve this. So I subtract 5 from both sides and I get 60 equals x. So the shortest way in doing this, I got there in 2 steps. Now, you guys have been mostly silent I have picked up the pace a little bit because I want to do one more example, and we're at 9:49. Do you guys have any questions about this? We are gonna spill over in just a second because I want to do one more problem with you. Okay. Hey guys, I know it's 9:50. We're gonna do one more problem. I'll do it quickly. So I'm gonna have this one. So we're gonna call this example 3. I'll just make it quick. I'll call this same start, so 136 degrees, and then I'm going to call this 7x plus 9, and then put parentheses around it with a little that. Now, again, I was going to have you guys try this one on your own, but we don't have time. So these don't have a direct relationship. So again, I just need to find another angle that will allow me to get a direct relationship. It could be a linear pair and do alternate exterior. What I'm going to do is I'm going to do corresponding. Right? So this is if parallel lines, then corresponding angles are congruent. Right? So I did corresponding angles. If this is 136 and these are parallel, do you guys see how they're parallel? So if parallel, then these angles are going to be the same. If those angles are the same, then, right, so this was step 1. Step 2, that's a linear pair. So 136 equals 7x plus 9, and that is a linear pair. Hey guys, if you need to take off, go ahead and take off, but I am going to solve this algebraically. Okay. Yep, hey, bye. And I'm just going to solve this really quickly for the people who need it. So I get 127 equals 7x. And then I divide by 7. I feel like I did something wrong. Oh, you know what I did wrong? They don't equal each other. That's not a linear pair, is it? So I made a mistake. So 136 plus 7x plus 9 equals 180, right? So that's what this needs to be. So that's a mistake, isn't it? Gosh, Kraft, making mistakes. They add up to 180. So I'm going to combine like terms. So I get 136 plus 9. That's 145 plus 7x equals 180. So I combine like terms. And then I subtract 145 from both sides. So I get 7x equals, so I go 180 minus 145. I get 35. I divide by 7. I get x equals 5. Okay. Sorry, guys, that we ran out of time. It's just 50 minutes isn't a lot. Make sure you guys work on your homework. If you need help, please come see me in my office hours. They're all in the morning now. And take care. Good luck on your homework. And I hope you guys have a good weekend.